Hello again, dear students, for completing 3.2 the second video. In this video, I'm going to finish 3.2, and as we stopped in the page 94, the previous one, now we are going to continue guidelines for graphing the polynomial functions. First of all, you need the zero, and when I say the zero, we mean factoring the polynomial to find in all zeros. Also, test point, I will show you later, and you know about the end behavior. Finally, you can sketch the graph, because the plotting some graph like that is very easy, because you have three keys. They are very important for sketching polynomial function. When we say polynomial function, I mean I doesn't mean the easiest or the standard or the usual. We mean there's something like that. Now in this example number 4 in page 94, we have what we asking about sketching the graph P. Example 4, page your lecture note, page 94. In this one, we have a p of x is equal to x plus 2, x minus 1, x minus 3. He says sketch the following graph. You know, first of all, because you have a factor in the example, so means that in the guidelines you passed the first key. You have got a key. You can do it easily, because here's your factor. Now where's the zeros is equal to what? Because you have a factor, so factor, yes. And now it's a time for writing 0. 0 is equal to what? Tell me. That is very important. We have minus 2, 1 and 3. So now before I am sketching, I know in my graph I have 3 points intersection. 1, 3, minus 2, because I go zeros, they are coming from that factor. Now go to the second key. We set test points. When we say test points, means that write down these zeros, 1 and 3, and choose the value less than 2, between less than minus 2, between minus 2 and 1, between 1 and 3, and greater than 3. For example, I'll choose minus 3, and I will choose 0, and I will choose 2, also 4 as a test point. Okay, dear. So for this one, you need test points. So the second key of us. Why? We have p of x is equal to x plus 2, x minus 1, x minus 3. It's the key 0. It's the key 0, and please try to put the test points to substitute test points in this point here. So I'll put p of, now we have minus 2, 1, 3. Now for this purpose, we should find the test points here. Like if I put minus 3 here, I will put it minus 3 here. I'll get what? I'll get minus 3 plus 2, minus 3 minus 1, means that substitute minus 3 here in the polynomial function, the original one. Now I get what? I get really, we don't care about the value here. We just care about the sign. For example, minus 2 plus minus 3 plus 2, I get negative, and here also I get negative, and here also I get negative. Negative is positive, multiplying last negative is equal to negative. Means that, write down here, negative means that my graph is write down here, okay, negative means that my graph is going to decrease. Okay, how about between minus 2 and 1? If I put 0, I get what? 0 plus 2, 0, minus 1, 0, minus 3. So here I get positive, again negative, and again negative. So positive by negative, negative, negative by negative, positive. So means that between minus 2 and 1 I have a positive, means that they have the increasing. Okay, my function is increased, so going down x-axis, going to up x-axis. Okay, how about the value between between 1 and 3? So I will choose 2. So if I put 2 here, I get what? Now directly I will do it. 2 plus 2 is equal to 4, so means that positive. 2 minus 1, I get 1, so means that again positive. So 2, I will get negative. So positive, 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 negative. I will get negative here, means that decreasing. Again, try to put the value for substitute value in the original function or polynomial function. If I put 4, 4, 2 is positive. 4 minus 1 is 3, positive. 4 minus 3 is 1, positive. So I'll get positive again, means that my function behaved to up, and here behaved to down. So the our function is going downward, or this in here is going to upward, or up over x-axis and lower of x-axis and above of x-axis. Now this is the second key by using the test points. And the third one is what? The third one is end behaviors. Okay, in the end behaviors, we need the leading term. Where's our leading term? X plus 2, x minus 1, x minus 3. We should multiply this one. So I will get what? X by x. I will get x squared. Okay. And again by x, I will get what? X cubed. And something like, and there's the rest numbers here. But I don't care. Why? I'll do it for you and I will show you why. If I multiply this one by that one, I will get what? X squared minus x plus 2x minus 1. Again, multiply x minus 3. So here's x2. This one and that one, they are common. So I'll get x minus 1. Multiply x minus 3. Now I'm multiplying this one. I'll get what? X cubed minus 3x squared plus x squared again, and minus 3x minus x plus 3. Now combine and do the collection and arrange them. So I get minus 2x squared minus 4x plus 3. Where is leading coefficient? The leading coefficient is here, because our polynomial is degree 3. That's why here I say just I will multiply the first terms of the factors. That's why I don't care about the whole multiplication, because they are not important for me. So I get this one. So in general, the third key, I have what? I have odd. Oh, okay, positive or negative? They are positive. So tell me about the shape. The shape is something like that, right? It's like N, or you can say N, like that. Okay, as you have in the page 92, sorry, if I have a positive, the shape will be something like N. Okay, so that's why in this example I got the shape, I got the increasing and decreasing, also I got the intersection points. Now in the page 28 I'm going to finish, and you can also find these steps in your lecture note in the page 94 and 95, but really in your lecture note there's a little bit more complicated. I deal with this one simply for you, so I solve by the simplest way, and you are free for using any other methods. Just be logic and be mathematically correct. That's I don't care. So now here's the graph. We have what? We have 3, 1 and minus 2, and they are intersections. Okay, now I'm summarizing the information. okay? And we have negative, positive, negative, positive, you know, so means that increasing, decreasing, increasing, decreasing and increasing the graph. So I'm starting with the left of -2, we have decreasing, and I'm going to 2, between 2 and 1 I have increasing, okay dear, and between 1 and 3, between 1 and 3 we have again decreasing, okay, and after 3, okay, decrease. So I'm going to decrease, I'm going to 3, and after 3 I got what? I got increasing function, okay? Doesn't look like a better in here really. And how we know this is number 5? Maybe you're asking, it's a really good question, how we get this number, maybe 5 or more than that. So just let x be 0 and you get the number. For example, I have a p of x is equal to x plus 2, x minus 1, x minus 3. So if I say p is equal to 0, because if x is 0, I will get y, right? So I get what? 0, 0, 0. I get 2 minus 1 minus 3, which are 3, 2, 6. So this point is equal to what? It's not 5, it's 6. So because I got 0 and 6, there's the intersection with the y-axis. So how I get this is really not necessary, but you need for more. Let me say it's necessary because it will make your graph more nicer. You cannot overcome going up to 6. So finally, if I say 6, 1, 3, minus 2, my graph is something like that. Okay. So here's the shape, and you know, and behavior, because I have an odd positive, look like that. Our behavior look like that. So y-intersect is very important. You can rename it as now key number 4, even they are not mentioned in your lecture note, but really is important. It will make your graph more acceptable, and by letting x to be 0, so p of 0, you get y-intersect. Okay dear, as I do it here, I put y to be 0, so you get a value. Now we have another example here, example number 5. Please, I will leave it for you as a homework, because they are the same like example number 4, but the difference is what you should add the one step, which is factoring these polynomial or this function by just factoring. You know, we have x is a factor. Now you got something like that, and try to factor this trinomial again. You get here. So the zeros is what? Is -1, 3, and 0. You know, because x is equal to 0 for that one, and x is equal to 3 for the second factor, and x is equal to minus for the third factor. Okay dear. So now you have 3 points. They are very important, and here's the 0 and -1 and 3, right? So 3, 0 and -1 is our zeros, and go follow the guidelines, and do not forget about adding the y-intersect. I'll put y-intersect. Look, if x is equal to 0, I get what? 0. Multiply this one, I get 0. Put 0 here or there, they are the same. You get y0. So y-intersect is what? Is 0, 0, not 0, 6, like this example. No, it's not 0 and 6, it's 0 and 0. Okay dear. So that's about the page 95. Now I'm going to solve a different example for you. This is example number 6 together. Okay, so in the example number 6 we have what? We have example So do not forget about example 5. It's homework, page 97. Okay, 95. So example 6, your lecture note, I mean, page 96. Say, sketch the following graph. Just plot it. So x to power 4 minus x cube plus 3x square. Now it's the time to tell you how to deal with this graph. How we deal with this one? We will follow the guidelines. So first of all, solution. First of all, first key, which is what? So zeros. First, try to factor them, then find the zeros. So p of x, now have x squared as a common. Why? Because I can find the value. Also there's a minus as a common. I will get what? I get 2x squared plus, do you know why we plus? Just x and minus, because you have addition, and we took a minus as a common, so I'll get minus 3 only. Okay, dear. Now in the next step we have x squared minus x squared. Now we will factor this trinomial to 2x and x here, negative, positive, 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 negative. So I should have 3 and 1 here. Now I am combining them, 3x minus 2x. Now we will get what? We'll get the second or the middle term. Okay, good. So now the zeros are 0. Do not forget about this one. Also, if I say 2x plus 3 is equal to 0, I get what? I say 2x is equal to minus 3, x is equal to minus 3 over 2, minus 1.5, so minus 3 over 2, and what else? I say let this one be 0, so x minus 1 be 0, x is equal to 1, so also 1. And it's nicer in mathematics to write the negative, then smallest value to the largest value. It's okay. So we get minus 3 after letting this term to be 0. Okay, and 0 by this term, and x is equal to 1 by that, by after this one. So we are going to page 29 for the second key, which is what? Which test points. Okay, dear. So here's your point. I have 3, I think. Minus 3 over 2. Minus 3 over 2 means that minus 1.5. Okay, dear. Now I am selecting minus 2 in my mind, minus 1 here, and half, and 2. Okay, dear. It means that's your test point. Now we have what? We have p of x is equal to minus x squared. So I have a minus here also. 2x plus 3, right? And x minus 1. Now if I put 1.5 negative here, I will get what? Look. Okay, multiply 2 1.5 negative plus 3. Okay, 1.5 minus 1. I put p of minus 1.5. So 1.5 2 multiply 1.5 minus 1.5, as you know. Okay, so here we get minus number, any number, I don't care, I say negative. For the second part, 3 sorry. We shouldn't put this one. If I put this one, I will get 0 because it's intersection. I made a mistake, sorry. So I should put what? There is a test point. It's -2, right? So I'll get negative b here. So negative something squared 2 something plus x, sorry, -1. Okay, -2, -2, -2, -2. Okay, dear. So I get what? Negative value is equal to, you can write down, okay, to be the first one. 4. We have a negative, so I get negative. I get what? -4 plus 3 -3 because -2 -1. Now negative, negative, negative. Finally I get what? I get negative. So here is what? Here's negative and decreasing. Okay. How about between 0 and 1? You see you put -1. I get what? -1 squared 2 multiply -1 plus 3 -1 -1. Now I get what? Negative as usual. So you don't need to do every time here because you have a positive and negative. You get negatives here. You have a square. 2 negative. I will get positive, and here negative, negative. So negative, positive, negative, 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 positive. So finally I get positive here. And don't say that every time I will get negative, positive. No, this is not true. So please try to test all the points. Do not follow your mind, okay? Follow your logic. So do it by yourself. Do not say maybe negative, but not, you haven't every time something like alternative things, negative, positive, positive, negative. No, will change. Maybe in those examples they are the same, but in the general we have no something like that. To say if you get negative, positive, the rest one are like that, okay? So please do not do this mistake. Maybe in your lecture note, in your exercise, something like that. You are facing some problem like that. Okay, for the next value p of 0.5, I will get what? Negative value. 2 half means that 1. I will get positive. Half means I will get negative. So again I get what? Negative, negative, positive. So look, you got positive here. Now again increase, okay dear. And for 2 test point, here is negative as usual, I know. 2 power 4 4 3 7 is positive. 2 minus 1 is positive. I don't care about the value. And finally we get negative, so it means that here is negative. Now our test point or our region for increasing and decreasing is like that: negative, negative, positive, positive, increase, increase, and decrease. Okay, now we finish the second part, and as usual in the example, as we had what? We had the example, we had p of x is equal to negative 2x to power 4 negative x cubed plus 3x squared. The leading term is minus 2x to power 4. So I got what? And the leading coefficient is negative, and this one is even. So I'll get even, even negative, e minus. So e minus is like m. You remember that. Now we will collect number 1, 2, 3, and do not forget about y intersect. If I put 0, y is equal, and I want number 4, number 3, number 4, as we add it together, y intersect, just let x be 0, then p of x or p of 0 is equal to what? 0, 0, 0, I get 0. So 0, 0. So I have this point. Now I'm sure that here's the 0, 0. It's minus 3 over 2, 1, and sorry, not 1, 0 and 3, yes, 0 and 1, sorry, we don't need this one. Both point are like that. Let me remind you of 1, 0, minus 3 over 2. Now in this example, I know here's negative part because say negative, positive, positive, negative. Okay, dear. So you should collect all, and you know about the shape. And because you have also between 0 and 30.2 you have a positive, so it means that we have something like that. And between 0 and I know because you have a 0, 0 here, and between 0 and we have again positive, so you should be have something like that. And larger one, we have what? We have negative again. Here's your shape, and you can find you got something like that in your lecture note. So follow this one. Again, an example number 7. I will leave this one for you as a homework. Please do it, because in the exam you will face some examples like example number 5 and 7, and really one of them they will come and you'll see the example in the exam, and the other one might be maybe in their exercise. So please try to solve example 4 to 7. Yes, please try to solve 4 to 7. Okay, by your hands, they are very important. Okay, dear. I will leave this one as a homework for you. Number 5. So example number 5, 95, and example 7 in 96. They are homeworks, and maybe I need it in the report or something like that. Otherwise, you'll face them in the exam. And try to solve example 4 to 7, all of them by your hands again and again, because if you cannot solve this one, you cannot overcome this subject, because this subject is very, very important, and especially in the final exam. Now, I'll leave this 96 till here, and here's your solution. You can follow this one, and please cancel numbers 97, local maximum and minimum. Please cancel this local maximum and minimum also. 98, all of them cancel with the exercise as usual. As I say, if we cancel some subject, of course the exercise will vanish. And here's your 99, your exercise. Please try to solve these examples, especially from 4 to 7 in your lecture note. They are very important. Now we are finished our finish our lecture about 2.3. Now 3.2, sorry. Now next section I'm going to record 3.3 with different things. It's very easy, more easier than this section. So they in this section, do not forget to follow the example number 4 and number 7 and 5 and all of them. Thank you for watching the video, and next session you'll see we have another video about 3.3. Thank you very much.